Hello dear friends, today we discuss unit number 3 part C, aliphatic hydrocarbon, reactions of alkenes. Now dear student, in previous lecture we discussed about the alkenes. What is meant by alkenes? Preparation reactions of the alkenes. Now here in this lecture we discuss chemical reactions of alkene. Now myself, Dr. Suryakanth Borul, Assistant Professor and Head of the Department of Chemistry, Lect Durga Kanal Banmiro Science College, Lonar. Now here, before we discuss about the reactions of alkene, first what is by alkene? Alkene is nothing but the aliphatic unsaturated hydrocarbon containing carbon-carbon double bonds, and they have general formula CnH2n. That means here it is an aliphatic unsaturated hydrocarbon. Dear student, you know that unsaturated is nothing but the carbon-carbon double or triple bond. That means multiple bond containing compounds, and hydrocarbon means compound containing carbon and hydrogen. So here hydrogen and carbon containing compounds having carbon-carbon double bond. So they have general formula CnH2n. That means as compared to the alkene, two hydrogen atom less, and which is get converted into to fulfill the valency of carbon atom by formation of double bond in between carbon atoms. Again, you know that alkene is also known as olefins. Now few examples of alkene here. C4H8, that means here butene or butylene. But dear friend, is the molecular formula of butene or butylene. Now this butene and butylene having a two structural as CH3 CH double bond CH single bond CH3. That means here double bond in between these middle carbon atoms. That means carbon number 2 and 3. Now in another structural formula, double bond in between carbon number 1 and 2. Both the structures have same molecular formula C4H8. But here, in this case, the first structure C3CH double bond CH single bond CH3 is a symmetrical alkene, while the another structural formula CH3 CH2 CH double bond CH2. These are unsymmetrical alkenes. That means here, depending upon the position of double bond and number of carbon atoms, there are two types of alkenes: symmetrical and unsymmetrical alkenes. Again, we discuss one more example for symmetrical and unsymmetrical alkene. C5H10. Now this is a molecular formula of pentene, or which is also known as pentylene. Now the structural formula in pentene CH3 CH2 CH2 CH double bond CH2. That means here double bond in between carbon number 1 and 2. But another structural formula double bond in between carbon number 2 and 3. So both have same molecular formula but different structural formula. That means these two alkenes, both are alkenes, but these two alkenes are different. Now in this case, both alkenes are unsymmetrical alkene because symmetry around the double bonds. That means here both sides of the double bonds having same number of atoms. Such alkene known as symmetrical alkene, while both the side of double bond have a different number of carbon atoms, that means unequal carbon atom or unequal atoms, such alkene known as unsymmetrical alkenes. So from this example it is clear that there are two types of alkene: symmetrical alkene and unsymmetrical alkene. Now for the reactions of alkene, in first case, reaction with symmetrical alkene and reaction with unsymmetrical alkene. So we discussed what is meant by symmetrical alkene. Symmetrical alkene is nothing but alkene which have same or equal number of atoms on the both side of the double bonds. Such alkenes are called as symmetrical alkene. Example, in case of butene 2-butene, in case of hexene, now this is hexene, hexene 3-hexene. That means here in case of symmetrical alkene, same number of atoms on the both side of double bond, simply. Now in case of unsymmetrical alkenes, the alkenes which have different or unequal number of atoms on the both side of double bond, such alkenes are known as unsymmetrical. Different or unequal number of atoms on the both side of the double bonds, such alkenes are called as unsymmetrical alkenes. Example, butene 1-butene, in case of pentene 1-pentene and 2-pentene. This is known about the symmetrical and unsymmetrical alkenes. Now move towards chemical reactions of alkene. Now first chemical reaction, hydrohalogenation of alkene or addition of HX, or which is also known addition of halo acid. Now hydrohalogenation means here addition of halogen as well as hydrogen. Now first addition of HX or hydrohalogenation of symmetrical alkene. In second B part we discuss about hydrohalogenation or addition of HX in unsymmetrical alkene. So we discuss one by one. A, addition of HX in symmetrical alkene. Now in case of symmetrical alkene, there is a simple reaction. Symmetrical alkene react with HX or halo acid, then it gives alkyl halide. Simple. Now here, for example, ethene react with HBr, then it gives ethyl bromide. One more example, for example 2-butene, it react with HBr, then it gives 2-bromobutane. 2-bromobutane. Now this is the addition of HX in symmetrical alkene. Now addition of HX in unsymmetrical alkenes. Now in this case, the addition of HX in unsymmetrical alkene, it gives the mixture of alkyl halides. It gives mixture of alkyl halides. For example, propene react with HBr, it gives 1-bromopropene and 2-bromopropene. Now here propene is an example of unsymmetrical alkene. So it reacts with HBr, it gives a mixture of 1-bromo and 2-bromopropene. Now reaction adds CH3CH double bond CH2. Or this is a structural formula of propene. Would react with HBr, it gives 1-bromopropene and 2-bromopropene. Here mixture of 1-bromopropene and 2-bromopropene obtained, but which product, that means it may be 1-bromo or 2-bromo, is major products. So according to Markovnikov rule, according to Markovnikov addition rule, 2-bromopropene is the major product. 2-bromopropene is the major product. Now here, so question as, what is the Markovnikov addition rule? Or state and explain Markovnikov addition rule. That means here, in case of addition of HX in unsymmetrical alkene, the Markovnikov addition rule is important. So next question as state and explain Markovnikov addition rule. Markovnikov addition rule. So Markovnikov addition rule stated that when an addition of unsymmetrical reagent For example, HX. In an unsymmetrical alkene, then the negative part of reagent, that means X negative, get attached to the double bonded carbon atom which carries less number of hydrogen atoms. Less number of hydrogen atoms. Once again, Markovnikov rule stated that when an addition of unsymmetrical reagent in an unsymmetrical alkene, then the negative part of reagent get attached to double bonded carbon atom which carries less number of hydrogen atom. Now that means here simple unsymmetrical reagent as EHX, halo acids, which is react with unsymmetrical alkene. That means, for example, propene, 1-butene, pentene, etc. The negative part of that reagent, that means X negative, halogen, get attached to the double bonded carbon atom after breaking the double bond in between that carbon atom. Get attached to the double bonded carbon atom. Those carbon carries less number of hydrogen to which halogen atom get attached. Now here, for example, when propene react with HBr, then it gives 2-bromopropene as a major product. Now in here propene, double bond in between these two carbon atom, that means CH and double bond CH2. Now HBr, addition of HBr in the unsymmetrical alkene, so negative charge, that means Br negative, get attached to the double bonded carbon atom which carries less number. So here CH carries less number of hydrogen atoms, so Br get attached to the CH. In this way it gives 2-bromopropane. Okay, that means here in this reaction Br negative ion get attached to the middle bonded carbon atom of propene, because according to Markovnikov addition rule, because this carbon carries less number of hydrogen atoms. Okay, this is the statement and explanation of addition, Markovnikov addition rules. Now one more example related with the Markovnikov addition rule. When 1-butene react with HBr, it gives 2-bromobutene. Now this is 1-butene react with HBr. Again here Br get attached to CH. Why? Because which carries less. Now here CH2, that means less number of hydrogen here. So Br get attached to this carbon. In this way it gives 2-bromobutane. Now what is the actual mechanism? What is the mechanism of this reaction? Now explain the mechanism of addition of HBr to propylene. Many times this question asks in university examination for 4 marks. Explain the mechanism of addition of HBr to propylene. Now here propene or propylene react with HBr, it gives 2-bromopropane according to Markovnikov rule. So here CH3 CH double bond CH2 react with HBr, it gives CH3 CH Br CH3, that means 2-bromopropane. Instead of propene here propane. Now what is the mechanism of this reaction actually? Now mechanism of this reaction is in 3 steps, and these are as follows. First step, formation of electrophile. In first step first, formation of electrophile. Now how form the electrophile here? Here HBr undergoes heterolysis or heterolytic bond fission take place in between HBr. So it gives H positive and Br negative. Now here H positive acts as the electrophile while Br negative acts as a nucleophile. Okay. Now here H positive, that means electrophile, is important. So this step is known as the formation of electrophile. Now what happens in second steps? In second step, formation of carbocation. Now in this step proton which obtained in the first step as an electrophile which is attacked on propylene to form primary carbocation which is less stable and secondary carbocation which is a more stable. As now this is a propylene CH3 CH double bond CH3, okay, and now this is H positive, that means the proton from the step first. So now this proton in first case, addition of the proton at a CH2, so it gives CH3 CH positive CH3. Why? Because this electron pair shift on this carbon atom, so this carbon carries negative charge while this carbon carries positive charge. Now the proton get attached to the nucleophile or negative charge species, so it gets converted to CH3. In this way it gives carbocation which at a secondary carbon, that's why known as secondary carbocation, which is a more stable. Now in second case, H positive get attached to the here middle carbon as the electron pair shift on this carbon atom. So in this way it gives primary carbocation which is a less stable according to stability of carbocation. Secondary carbocation is more stable than that of the primary, so this secondary carbocation is more stable. So this step is known as the formation of carbocation. What happens in step 3? In step 3, formation of product. That means here more stable secondary carbocation react with nucleophile, that means Br negative, which obtained in a step first. So the secondary carbocation react with Br negative, it gives 2-bromopropane. That means here simple, Br negative get attached to the deficient center and to form 2-bromopropane, or which is also known as isopropyl bromide. That means this is the actual mechanism of addition of HBr to bromopropane, not propene, propane. Thank you, dear student.